Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today to learn Fusion 360 or die trying. We're here today with lesson number 9, and what we are going to learn is we are going to learn how to make gears. Okay, we are going to learn how to make gears, and we're actually going to spend several lessons on learning gears, and we're going to start with some simple things today. And what we're going to talk to you today about is how to make helical gears. The helical gears are gears that, if you look here, we have the gear teeth sort of slanted. Now, why would you want to make slanted gear teeth? Well, the strength of a gear is based on how thick the gear teeth are, how thick those teeth are. And so if we want a strong gear, we need thick gear teeth. But you really don't want a thick gear because that uses more metal, generates more inertia, all types of reasons that you don't want a thick gear, but you want big gear teeth. So what you do with a helical gear is you sort of tilt the gear teeth, so for a thinner gear, you still get a big gear tooth. You sort of lay it over where you get a big gear tooth but a small gear thickness. So it's kind of a neat idea. All right, let me get out of your way and let's just jump right into this. Let me scoot down here to get out of your way. And the first thing that you're going to need to do is you are going to need to get a plug-in, because you would not want to, or at least I would not want to, try to draw all these things by hand. So you want to come over here and you want to come to add-ins and you want to say Fusion 360 App Store. And so I'm going to click on that. This nonsense pops up. And then what I want to say is I want to look at add-ins for gears. Okay, I click on gears. You can see all of these different ones, and the one that you want is this one right here that says helical gear generator, and you're going to click on that. Okay, then you're going to click download. And then when you click download, it will come up. I want you to sign in. You need to sign in to Fusion 360. What you're going to do is you're going to sign in, and then you're going to download. It should show up down here. You can imagine I've already downloaded it, but it should, stop that nonsense. It should show up down here. And then once it shows up and is finished downloading, you click on it. That will install it. And then after it's installed, you will come up and you will look under Create, and you will have something new that you can create. You can create helical, I wish I could say that. That's a hard word to say, helical gear. You can create a helical gear. All right. So now what I need you to do is let's start a new design. Okay, and here we are with a new design, and we are going to jump right in and we are going to create our first gear. You don't create it as a sketch, you create it as an object. So you come over here under Create, you come down to Helical Gear, and you come over here, and we'll talk more about right and left gears, but right now we'll just leave it like it is, a right gear. We will have the normal system. The main thing is a lot of different things will work, but you got to just think that if you're going to make two gears, they kind of need to have certain aspects the same. So this one's going to be normal, this gear is going to be right. The helix angle of 30 degrees, that's pretty good. The pressure angle 20 degrees, those are things you don't really need to worry about right now. We'll talk a little bit about the helix angle a little bit later, but a pressure angle of 20 degrees is pretty good for a gear. The module 3 millimeters, that's just kind of how big, you could think of it as sort of proportional to how big the gear is. So the bigger the gear, then the bigger the gear tooth, the bigger the gear is going to be. So the module is kind of like roughly related to the size of the gear. How many teeth you want? Okay, here we've got 16 teeth. I think I'm going to make this one 18 teeth. Okay, and then the backlash is sort of like how much slop that you have in the gears. I'm not going to put any backlash, and I'm going to kind of have tight fitting gears, and you know, we can talk a little bit more in later lessons about backlash. But and again, we're trying to make things that are 3D printable, so we're going to just make this for 3D printing. And then the gear thickness, the backlash, we're not going to put any in, and the gear thickness 10 millimeters, and then we're going to say preview. Okay, now you can imagine that we want both gears the same thickness, and we want the same helix angle and we want the same pressure angle in the same module, but you would have different number of teeth, but 18 is good for this one. So we are going to click OK. All right, and now the thing is, you notice how it didn't give me any option of where I was going to put this thing. Okay, it just put it there. So now I need to kind of get over there and get it out of the way so I can make another gear. So I'm going to say sketch, create sketch. Let's create a line. Where is line? There it is, right up at the top. Okay, where do I want to sketch? I want to sketch on the XY plane. I am afraid I might select that gear face, so I'm going to scoot it around, right mouse click OK. I want to sketch in the XY plane. Okay, so now you see I'm sketching kind of at the flat of the bottom of that gear. And I'm going to move this out of the way. What I want to do is I want to go over the origin, click once. Okay, I want to come out, click again, click OK, click escape to get out of that tool, right mouse click, make this a construction line, normal construction, and then I want to dimension it. So I click D, I come here, I come down, and then let's have that set at 75, enter. Okay, now why did I do all this nonsense? Because I want to move this thing over here and I want to have a spot for it to land. Okay, so I'm going to say stop sketch, right mouse click, I am going to move. What do I want to move? I want to move a component. Now you notice over here it created the gear as a component, and that's good. It makes it easy to work with. So I'm going to come over, I'm going to say select the component. Okay, I want that component. I want to do a point to point move, so I get point to point. What point do I want? I want that point, and I want to move it to that point. Okay, I got that thing moved. Now I want to go ahead and kind of finish this gear up, and so what I want to do is I want to come in and I want to edit the sketch again. So I'm going to say edit sketch. All right, and now what I'm going to do is I'm going to draw a circle. So I'll tap C, the shortcut for circle. I'll come here, come out, click. I've got a circle. Now what do I want to do? D for dimension. I D for dimension. I come here, I come out. I want this to be 10. Okay, 10 millimeters. Boom. Now you see when I did the sketch, it kind of put the gear back in this spot. Even though the gear's not there, it'll work out, but it's just kind of quirky the way it does things. So now I'm going to say stop sketch, and boom, I'm back in the right spot. And so this gear component is in the right spot and it's over that. I want to cut that hole in it. So what am I going to do? I'm going to select that, or I'm going to say extrude, create an extrude. And it says the gear's in the wrong place. Do you want to leave it there or put it back where it was? Well, I want to capture the position. Yeah, I want to move it over there. Now hopefully it'll stop showing it back in that old location. Now what do I want to extrude? I'll select the profile of the hole. Okay, and I want it one-sided in a profile plane, and then I can just lift it up, and you see it turns it red. What did that do? That cut a hole in that gear. Is that not lovely? And let's kind of look at it from this view. Right mouse click. What is that tool? Okay, click on it from that. Okay, so you see we have got the gear over here and it's away from the origin. And I believe we did 18 teeth on it. Man, we're moving right along. What do we need? We need a second gear. So what do? Come up to create, and then we're going to say helical gear, and then we're going to keep the 30 degrees and the 20 degrees. We're going to keep normal, but we really have to think about the right-handed and left-handed nature, because I want you to think, you see how those gear teeth are askew? Okay, if we made them both identical, where this one is tilted this way and this one is tilted this way, they're both right-handed, what happens when they're going to rotate towards each other? What's going to happen when you get here? Do this with your hands. They're not going to mesh. They're going to hit on their ends. So what do we need? We need one this way and one this way. Now what happens when they come together? They meet, or one this way and one this way, then they come together and they mesh. So if that first gear was right-handed, what does this one need to be? You got it. it needs to be left-handed. So we'll make this one left-handed, okay? We'll keep the 30 degrees and the 20 because that needs to match. The 30 degree as far as the helix angle, that's like how far tilted it is. So if I made it 45, it'd tilt over further and further, but 30 is pretty good. 20 again is the pressure angle, that's good. Instead of 18 teeth, we are going to go for 12 teeth. Okay, so this will be a smaller gear. You know what I like to do? I like to put preview on here as I'm doing this as well, so you can kind of see what the gear is going to look like. And do you see this gear? It's like tilted one way, and the other gear is tilted the other way. And so if we look at it, we can see that those are really going to mesh because I made one right-handed and one left-handed. 12 teeth. That looks good. We are going to say okay. We want to move that one out of the way as well. And so let's go back to our sketch. I will click here on sketch, turn it on, and then I will say edit sketch because I don't really need to make another one. And I'll create a line again. So I type L and I click here, and then I'll come out to 75 again, click check mark, escape to get out of the line tool, right mouse click on the line and say normal construction. Then what I want to do, dimension, so I type D for dimension. I come here, I pull down, and let's put it at 75 again. Okay, enter, and now I've got a little thing there. What do I need? I need to move it, so I'm going to say stop sketch. All right, and now you see I've got the two gears. I want to move this one over here. I'm going to look under it so I can make sure to get that point that it's sitting on. So let's kind of tilt down under it, and then let's go here, and let's go here. Okay, and now right mouse click OK to get out of that tool. What do I want to do? I want to right mouse click and I want to move. What do I want to move? I want to move a component. I've got to select the component. Give me that gear. I want to do a point-to-point move, and then I'm going to select the origin point. I want to move this point, and then select the destination point. I want to move to there, and boom, look at that. Man, we are going great. Okay, somebody tell me what we need to do next. Anybody? Anybody? What do we need to do? We need to put a hole in that gear. Okay, let's come back to sketch. So I'm going to come here on this sketch. And you know what? I'm glad this happened. If you ever try to right mouse click on the sketch and it's not giving you the option, that's because you're still in the rotate tool. Come over here, right mouse click, say OK. We're out of the rotate tool. Now I can right mouse click, edit sketch. What do I want here? I want a circle. So C. Hover over, let it snap, click once, pull out, click again. What do I want to do? Dimension it. So I tap D on the keyboard, got my dimension tool, come here, come out, and what do I want to dimension that? I want to dimension it at 10. Okay? So enter, boom. Now let's stop sketch and look at that. I am ready to extrude that. So I select that and then I say create and extrude. Okay. Do I really want this stuff? This bothers me. I moved it, but it doesn't really acknowledge the move. It says some components have moved. Do you want to capture them in their current location? Yeah. I wouldn't have moved it if I didn't want it here. Okay. So capture position. Yes. Okay. I want to select the profile. It's already selected. And I want to just come up and pull it up through it. That red means that it's a cut. You can also see here it knew that it was a cut. If for some reason it didn't know that and tried to make a post, you would come over here and say, no, make a cut. Now, okay. Look at that. I've got two gears. And these gears would, in fact, mesh together. Okay, now what I need to do is I need to kind of make a base for these things to sit on so that they can sit and spin together. So sort of like we're making a little fidget toy. So what I need to know is I'm going to right mouse click OK to get out of this. What I need to know is I need to know kind of how far it is, like what is the outside diameter of this big circle. So I'm going to write this down and we're going to kind of have to figure it out, outside diameter. I haven't figured out a way to measure it on the body or the component, so we need to go back to sketch and I need to just say like create a sketch, and then I'm going to create it at this top surface, at this top plane of the gear. Okay, there I am. Now I'm going to do D for dimension, D. And if I come here and just click on this and come out, do you see how it's giving me a radius? Okay, it's going to tell me the radius. The radius of this gear is 34.177. And that really seems to be a radius, not a diameter, doesn't it? Doesn't that seem to be a radius? Let me just check it. Let me do a dimension to make sure that that's a radius. And let's see if I could go from here to here just to be sure. Yeah, you see, that was a radius. Okay. Come on, there you go. And so I'm going to trust the radius, even though it's a little bit different than what I'm doing here, because you can see it's more of a perfect measurement. Okay, so the radius is 34.177, and I'm going to go ahead and calculate the diameter. And so the outer diameter is going to be 34.177 times 2 is going to be 68.354. I need to write that down. Okay, the other thing that I need to know is I really need to know kind of this inside diameter, so I'm going to click D, and I'm going to click stop that right here, and stop that nonsense. Okay, I'm going to click off, so nothing selected, click D, select that segment, and it comes out and it gives me a radius of 27.427. So I'm going to take 27.427 times 2. That diameter is 54.854. So that's kind of like the inside diameter, and the other one is the outside diameter. And this is the big gear. So let's write this down. Big gear, and those are the two dimensions. Because if I'm going to make a base plate, I need the radius of the circle to be kind of like between here. You know, I need it to match so that this thing sits on the base. Okay, and we're going to need to know the same thing here. So I'm going to come in and I'm going to stop this sketch, and I'm going to edit this sketch. So I will say, I guess I will need to create a sketch. So say come down, create a sketch. I want it to be on this plane. Okay, so I can measure things. And now I'm going to go D for dimension and give me the dimension of that circle. And that is going to be 23.785. I want diameter, so I'm going to multiply it by 2. So 23.785 times 2 is equal to 47.57. And then similarly, I'm going to get this one, so come here and come out, and that is 17.035, 17.035, okay, times 2 is going to be 34.07. So I'll write that down. 34.07. Okay, so we kind of have the inside diameter and the outside diameter of both gears. Okay, so let's say stop sketch, so we kind of know what we need there, right? We know how big these gears are. Now what we're going to do is we are going to start the base. And to do the base, we want to go back to that original sketch plane where we put the circles and stuff, because it's down there on the XY plane. So I'm going to come here and I'm going to say edit the sketch. Why won't it edit? I'm hitting right mouse. It's not working. Why? Because I got to get out of the rotate tool. Right mouse click, OK. Now right mouse click on sketch, edit sketch, boom. Okay. Now, do you see how he keeps putting this gear back there? Because that's where it started. Even though I moved it in Sketch World, it still wants to put it there. Kind of quirky, kind of annoying, but what I'm going to do is I'm going to turn it off, and it disappears right on that helical gear, that body. Okay. I'm just going to turn it off. All right. Now what I'm going to do is I'm going to draw a circle. So I say C. I come here, hover over, draw the circle. This is going to be the big one. And so I'm going to click Escape and then D for dimension. How big do I want that? I want that to be right flush and nice underneath the big gear. And so what was the outside diameter of the big gear? It was 68.354. Enter. Boom. What do I want? I want another circle. Don't worry so much about where you put it, but it does need to be directly above it. And so I'm going to say circle, and I'm going to come here. I've snapped to the grid, or I've snapped to the axis. Click, draw. Okay, D for diameter. Diameter of this. What do I want it? I want it the outside diameter of the smaller gear, which was 47.57. 47.57. Enter. Boom. Okay. That looks good. So you've kind of got the big gear and the small gear placed for them. But I want to kind of make a base, so I'm going to make a line, L for line. All I've got to do is anywhere on this line, you see it snaps with the X, click, come up here to somewhere else, click, come here and click, come here and click. All right. Right mouse click, say OK. Now, to make this neat and pretty, I want these all tangent, and then you'll get that nice smooth curve. So what do I want? What tool? I want a constraint, and I want the tangent constraint. I want this line tangent to this circle. Boom. I want this line tangent to this circle. Boom. I want this line tangent to this circle. Okay, and I want this line tangent to this circle, and it already was. And so now, do I want to top sketch yet? Not quite. Okay, not quite. So I've got a place for the big gear, I've got a place for the small gear, but what matters? That spacing between the big gear and the small gear. And you've got to think, they're going to be meshed, so I don't want the centers apart by the two outside diameters, because then they would meet right at the tip of the teeth. I don't want to have them apart by the sum of the inside diameters, because then they would be too close, they wouldn't mesh. What do I want? I want the outside diameter of one that would come out to here meshed with the inside diameter of the other one, and then the teeth would mesh. You could think of it as inside diameter plus one gear tooth. That would be the same as inside diameter of one plus the outside diameter of the other. Okay, now divide by 2, because we really want radius now, right? Because I want the distance between here to here would be this radius, outside radius, this radius, inside radius. All right, if that doesn't make sense, go back and look at it, listen to it again, or just watch how gears would mesh. You need the inside radius, one gear tooth, and the inside radius, or the inside radius and the outside radius, and they'll mesh. And that needs to be the distance between these 2 points, and so I need to say distance, and I need to come here. Whoa, what's going on? Okay, I guess I didn't draw a line up there, so I need to make a line, L for line, come down from here, come up here, snap, and then click OK. Right mouse click, get out of that, and then right mouse click, make it a construction line, D for dimension, come out here, and now how far do I want it? Well, I'll take one outside diameter of the big one, which was 68.354, plus the inside diameter of the other one. The inside diameter of the small gear was 34.07. That would be the diameters. But what I've got to do is let's be careful about it. Okay, let's do it the right way. The outside diameter is 68.354 on the big gear. What's the outside radius? Divide that by 2. So 68.354 divided by 2, okay, and that's the outside radius. Now I need to add to that 34.07, that's the diameter, divide by 2, that's the radius. Okay, and what do I get? I get 51.212. I guess it would have worked either way, but 51.212. Okay, boom. What does that mean? That when I put this gear and I put this gear, do you see this overlap? That's the overlap of the teeth. So if I just visually look at it, that looks good. What do I also need? I need posts for the gears to sit on. So those would be circles. I'll type C. I come out here. All right, now, how big do I want this circle? Well, the hole was 10, so I better not make the hole 10. That'd be kind of a tight press fit. I'm going to make the post 9.9. That'll give it a little bit of play. So diameter, D for diameter, and we're going to make this 9.9, enter. Okay, need another circle here, C for circle, click here, come out, D for diameter, come here, click here, and then what do I want? 9.9, 9.9, 90, not 99, 9.9, boom. Okay, does that look good? This does not look good. Let me try this again. For some reason, those don't look the same size to me. It does though. Okay, so it's saying those are the same. All right, let's see if there's any other constraints that I could do. For some reason, this thing is free to float around. That's not good. Let me undo that. Okay. Okay, so this I could probably set some constraints so this thing wouldn't fly away on me, but I'm not going to worry about that right now. Okay, so the one thing we need to do now is trim. So we're going to come up here and we're going to get the trim tool, and we're going to trim off these things that we don't need. Okay, see these segments that we don't need? Okay, now this is kind of annoying, but if you look at this, this is not a segment, that's just showing you where the diameter is, and this is showing you where the diameter is. So that's really not anything. Okay, so now I'm going to say stop sketch, and then I'm going to get kind of a good view on this. Okay, you know what, I'm going to change something. I'm going to come back here and edit sketch. This is something I should have thought of, so right mouse click, edit sketch. Okay, this line here, you know, one of the things I did, I kind of made it exactly the distance between the two gears, and therefore they're going to be in there kind of tight, and if things aren't going to be perfect, they're going to be sort of jammed in there. So to give them just a little bit of play, I'm going to add 1 millimeter to that dimension. So where I come over here and have 51.212, I am going to add 1 millimeter and say 52. Okay, boom. And that's going to move those posts out just a little bit, and that's just going to make the gears mesh a little bit easier, because remember, a 3D printer isn't perfect, so I'm just leaving a little tolerance there so the gears won't just kind of be crammed in there and not want to go down on the hub. Okay, so I can say stop sketch now and then get a better view. So what do we want to do here? Let's make this base and let's extrude it 3. So we'll say create extrude, and we're going to pull it up by 3 millimeters. Okay, 3 millimeter thickness on the base. Now we need to extrude these. Okay, let's say extrude again, create extrude. I want this one and I want that one. Okay, and then I want to pull them up, and look at that. If it tries to make it a hole, make sure it's a join. Okay, now how thick is the gear? 10. How thick is the base? 3. So how tall would I better make these things? 10 plus 3? Better make them 13. Okay, better make them 13. So I come up here and extrude them 13, which is 10 plus 3. Boom. Okay, now let's look at this, and let's see here. Okay, we seem to be missing a gear. Okay, look at this over here, this helical gear, it's turned off, so we can turn it back on. Okay, and now let's look at this. Okay, that looks pretty good. Okay, I'm going to right mouse click, say okay. I'm going to move. I like to print things as close together as possible, because any imperfections in the flatness of the build plate, the closer you print things together, the easier it is. And so I want to do a free move. I want to move this component, and I want to kind of move it that way. That looks pretty good. And I'll say okay, and then I want to move, and I want to select this component. I want to kind of do a translation, and so I'll move it that way a little bit. That says okay, and now let me spin this around. Okay, sometimes this doesn't work good, so I like to just come up here and say home. Now I'll spin a little bit from there. That's not touching, but it's close, and I kind of like that. That looks pretty good. So that is ready to print. Okay, so what we are going to do is we're going to send it to the 3D printer. So I'm going to come up here, say 3D print. Okay, and then what we are going to do is we are going to select all of these things, and that did not work. So let's cancel. Okay, and so let's see if we select all of these things, and then we come up and we say 3D print. Hold your breath. Sometimes it's kind of quirky. Yeah, boom. So you see, this is going to put them all in the STL file. And then I've already got this hooked up with Idea Maker and the Raise 3D printer. So I'm going to say OK. And then boom, they come up here. What I would say is I would slice it and then I would say print. So I'm going to go ahead and I'll say start, and then I will say slice. Okay. So it is slicing. Okay, and now I'm going to upload it to the printer. Upload. This might be different for your printer. So what I'm going to do at this point, I'm going to go ahead and tell it to print. Okay, and then what I'm going to do is I'm going to pause the video to let this thing print and then come back. So I'm going to be gone for a couple hours, but it's just going to be a second for you. 5, 4, 3, 2, 1, boom. I'm back. Okay. And printing was successful. Okay, our printing was successful. So let me come back over here. All right, let me get out of your way. Our printing was successful, and I printed it on the Raise 3D printer, and I will show you this is the base. So do you see that base? Let me see if I can kind of make it look like, it's hard to get things oriented. They're kind of backwards. Okay, so you see that is the base. And then we've got the big gear and we've got the small gear, and you see how they're helical. Also notice how they mesh. One gear is pointing that way, the other gear is pointing this way, and then they come together perfectly. Make sure you understand that. One gear has to be left-handed, one gear has to be right-handed. Now let's see what happens if we mesh these things. Oh, look at that. Very nice. You see very nice mesh, fit together nicely, spin easily, and not a lot of slop in there. So adding that millimeter of distance between here and here from the actual physical dimensions of the gears makes it fit very nicely and spin very nicely. This is just a great little fidget toy. Boom. Okay, hopefully you guys played along with me, and hopefully you've got this thing printing on your printer. You know how to make helical gears. Okay, one thing I want you to do is I want you to think about something, that when you put these gears on here, like let's look down underneath, this flat gear is rubbing on this base, and you've got a really large kind of contact area. So what I want you to do is I want you to come up here and I want you to make a little, here's a different gear that I did, make a little standoff, right? Do you see that little extrusion, that little lip? Okay, I want you to put that on here. Okay, you don't want to do it on the bottom, you want to do it on the top of the gear. So you would draw another circle, make it say 2 millimeters wide, so the circle radius would need to be like 12. Okay, and then make it about 1 millimeter or 2 high when you extrude it, and that way you'll have nice little rings that this thing will ride on. So that, like, if you look at this one that I made with the rings, I did use different parameters on the gear. If you look at this one, it's kind of tricky to get together. What am I doing wrong? I will get this thing together. I will not give up. Kind of got it upside down. Okay, there. You see how it fits together very nicely, and it rides up on those little rails a little bit. I want you to try for your assignment to add those to these to just make it a little bit better than what I did in this video. Okay, so these are helical gears. Why do we like them? Because we get a larger gear tooth on a thinner gear. That's why we like helical gears. That's why we started with these. I didn't do just a straight up and down extrude. You kind of see how to do this. But what you would really like is, the one thing that's not so good, you can see as this turns, it's kind of like you're introducing sort of a z-axis force. It's almost like you're trying to drive one of the gears out of engagement. You know that as you apply a torque, it's almost like you're trying to create the other one going up, like that. You see? So helical gears, they want to sort of ride, it's almost like you're giving a ramp for them to become out of alignment. So what do you really want to do? You would like to really have kind of like a right-handed one on top of a left-handed one, and then you would have a herringbone gear. Do you see that? That's like a helical right hand on top of a helical left hand. That's what we're going to do in the next video. We're going to learn how to make these herringbone gears. But I wanted to start with something that was pretty straightforward. I think this was a pretty successful project, and for a first gear, I think, you know, this was a pretty quick video, and this is a pretty nice device. Okay, guys, hope you liked it. If you enjoyed this video, think about giving us a thumbs up. Think about sharing the video with all your friends. Think about leaving comments below. I really appreciate your comments. I read all of them. I try to answer as many of them as I can. And so give me some feedback. Was this a useful lesson? Are you out designing gears, man? Am I just sitting here talking to empty space, or are there really people out there that are trying to get these things going, and particularly get them going on their 3D printer? Okay, Paul McWhorter from TopTechBoy.com. I will talk to you guys later.